Now let's do more about evaluating the limits for e. When we plug in 0 to the denominator, you will get 0. Therefore, you cannot just using direct substitution. There's nothing for you to factoring. So we will try rationalizing. In other words, we use a conjugate multiply. What's conjugate multiply? Basically, it's a plus b times a minus b. That equals a squared minus b squared. So if we have square root, like square root of a plus square root of b times square root of a minus square root of b, you will get square root of a squared minus square root of b squared, so that you can get the a minus b. We call this is a rationalizing the square root. In the future, when we deal with complex numbers, we use conjugate multiply to simplify. For example, like a plus bi times a minus bi. You will get a squared minus b squared. So for this denominator, you have 3 minus square root of x plus 9. The conjugate will be 3 plus square root of x plus 9. So that you will get the 3 squared minus square root x plus 9 squared. 9 minus x plus 9. So we do distributive property. You will get that 9 minus x minus 9 equals negative x. So top and bottom, we multiply by this 3 plus square root x plus 9. Then you will get limit as x approaches 0. We already figured out the bottom, that is negative x. So top is x, 3 plus square root x plus 9. Then we reduce. You will get limit as x approaches 0. Denominator is negative 1, 3 plus square root x plus 9. Then this time, you will plug in 0. You will get the 3 plus square root 0 plus 9 over negative 1. So that you can get 3 plus 3 over negative 1. That is negative 6. Now let's go to f. This is a complex fraction. So you need to simplify complex fraction first. How you simplify complex fraction? You will find the LCD. So you have 1 over x plus 1 over 4. 4 and x. 4x will be LCD. Therefore, for the limit as x approaches negative 4, you will do 1 over x plus 1 over 4. We multiply by 4x. And the bottom, you need to multiply by 4x also. So for the top, when you multiply by 4x, I will put the 4x as a numerator. Because you got to do distributive property. And then you reduce 4 reduce. So you get the limit as x approaches negative 4. Denominator, you have 4x times x plus 4. To the top, you have 4 plus x. Then you can reduce. This time, you will get the limit as x approaches negative 4, 1 over 4x. So you can just plug in 1 over 4 times negative 4. That is negative 1 over 16. Now let's go to guided practice 4. You are given a piecewise function. Then evaluate the limits if they exist. First of all, here's the rule for existence of a limit. You have to make sure the limits from left side and also from right side equals to each other. Then the limit exists. Therefore, for A, we want to figure out the limit as z approaches 7 of h of z. So check the domain 7. 7 greater than negative 4. Therefore, we just need to plug in here. Because 1 minus 9z is a continuous function. Therefore, we just need to plug in. So for A, that is the limit as z approaches 7. 1 minus 9z. You will get the 1 minus 9 times 7. So you get the negative 62. For B, limit as z approaches negative 4, h of z. For this negative 4, you have to be careful because the function you used when you figure out the limit from the right side is not the same as the one from the left. Therefore, you have to do z approaches negative 4 from right. You got to use this function. That is 1 minus 9z. So we plug in. You will get the 1 minus 9 times negative 4. You will get 37. But the limit as z approaches negative 4 from the left, you got to use this function, 6 times z. So you get 6 times negative 4 equals negative 24. Since these two are not equal to each other, therefore, this limit doesn't exist.